Welcome to my video on how to factor polynomials completely when you are given a root. Now sometimes the root that they give you is going to be rational, sometimes it'll be irrational, sometimes it will be complex. In this case, this is a root, also known as a zero or a solution. In other words, this is a number that when you plug it into this function, let me show you here. When you plug it into this function, you get a zero. The words zero and root are synonymous. So let's check this. -8, this is +4, +44 minus 40. -4 plus 44 minus 40. This is 40 minus 40, which is 0. Alright, so that's what we're dealing with here. We're dealing with numbers that fit inside of these functions and yield a 0. So here we go. I'm going to try to factor this thing. Now it's important to know the connection between a 0 and a factor. If x equals -2 is a 0, which it is, it's right here, then x plus 2 is a factor. The way that you do that is you always take your 0 and you go like this. You say, okay, x minus whatever the 0 is. X minus -2 is x plus 2. So there's our factor. That is one of the binomial factors here in this cubic equation. So what I want to do next is figure out the other factors. So what I'm going to do is divide out that root synthetically. I'm going to do some synthetic division. If this is a little bit confusing to you, go back and check out my synthetic division video. But just really quickly, this is a 1 coefficient, this is a 1 coefficient, -22 coefficient, and the constant's -40. So I'll put those coefficients down here, and I bring this 1 down, I multiply these two and put that number here, I add these two, I multiply -2 and -1 to get +2, I add these two, and then I multiply -2 and -20 to get +40, and I put it right there. I add those, I get 0. So that's my remainder when I divide -2 out of this cubic, which is good. So I have my factor x minus 2, which is x plus 2, and then what's remaining after I divide that out is, if it started as a cubic, now it's going to be a quadratic. So x squared minus x, these are my new coefficients, minus 20. So it's x squared minus x minus 20. And we want to try to factor that thing. So I'll bring this down. And what I'm going to try to do is factor this quadratic. So here we go. X minus, let's see, 5, x minus 4. X plus 4 rather. So let's check these to make sure that they sort of FOIL together to get the quadratic above. First times first, outside, inside, and last. Yep, it works. And I'm finished. I have the complete factorization of the function that I started with. And just if you're curious, that's finished, by the way. It says factor completely, I did. But the three solutions, or the zeros, are x equals -2, x equals 5, and x equals -4. So these are my roots, or my zeros, or my solutions, and right here are my factors. So that's the nice connection between those different words. Let's try another one. Number 2, here you can see that we have an irrational root When there's an irrational root, it's a little bit more complicated than the one above. And the trick here is, if this is a root, then it has a partner. Its partner root is -4 minus the square root of 34. And that sort of comes from the plus and minus of the quadratic formula. So what I want to do is turn both of those roots into factors and multiply them. So these are my roots. Let's turn them into factors. Remember, it's x, the rule is x minus that thing, x minus the root, so that turns into x plus 4 minus the square root of 34. Down here, x minus -4 minus root 34. Simplify. I'm going to distribute that negative inside, plus 4 plus square root of 34. So let's multiply these two together. Looks more confusing than it is. I'll show you why in a second. So if I multiply these two together, it's like a triple distributive property. What I'm going to do is take this term, multiply it by x, by 4, and by radical 34. And I'll probably just move this down here a little bit so I can get more room. So x times x is x squared. X times 4 is 4x, and an x radical 34. Alright, the next distributive property is 4 times all three terms. So it's plus 4x plus 16 plus 4 root 34. And finally, the last distributive property is negative root 34 times all these things. So it's negative x root 34 minus 4 root 34 minus just 34. Remember, root 34 times root 34 is just 34. Alright, so that looks confusing, but watch this. We're going to get rid of a positive x root 34 and a negative x root 34. We're going to get rid of a positive 4 root 34 and a negative 4 root 34. And we're going to simplify the rest of it. X squared, there are two 4x's, combine those together. 16 minus 34 is negative 18. So that whole thing, those two roots, as we turn them into factors and multiply them, turns into this. And it goes without saying that this quadratic can't be factored. I know that because it's literally, it came from the two roots that we had above, -4 plus or minus the square root of 34. So that is not factorable anymore. So what I want to do is, if I scroll back up to my original problem, I have a 5th degree polynomial. These two roots come from x squared plus 8x minus 18. That's where they come from. So I need to take this quadratic out of this 5th degree. And by that I mean I just need to do some division. So I'm going to do some long division here. So let's bring this, let's bring this down. So I have x to the 5th plus 7x to the 4th minus 28x to the 3rd. I'm just copying my original. There we go. And I know that this is one of my factors. So before I continue, what I would normally try to do from here is see if there are any GCFs, and there are. Right, there's an x in all these terms. So let's factor out that x. Let's take out an x out of everything. Alright, so this is another factor. Alright, which means if that's a factor, then x equals 0 is a root. So now I have over here my list of factors. I have the quadratic, x squared plus 8x minus 18, and I have x. So now what I want to do is long division out of this smaller version. I want to take this quadratic out of this big quartic. So here we go. X to the fourth, I'll copy it down here again. And I'm going to divide out that quadratic from it by doing some long division. So here we go. Long division, x squared and x to the fourth. I need to figure out how many times x squared goes into x to the fourth, and that answer goes here. It's x squared. Notice I'm keeping these lined up. And now I need to multiply back down, multiply this times all three of these things, just like we did back in, I guess, 4th grade when we learned long division, or whenever that was, maybe 3rd, I don't know. So x to the fourth plus 8x cubed minus 18x squared. Subtract, put it in parentheses, these cancel out. 7x cubed minus 8x cubed is negative x cubed. Negative 28x squared minus a negative 18, that's negative 10x squared. Bring this down. Next question, my lead term here, how many times does it go into negative x cubed? The answer is negative x. So I'll put that up here. Multiply that back down. So negative x cubed minus 8x squared plus 18x. Subtract. These cancel. Negative 10x squared plus 8x squared is negative 2x squared. 2x minus 18x is negative 16x. Bring this down. How many times does x squared go into negative 2x squared? The answer is negative 2. I'll put that right here. And I'll multiply back down. Negative 2x squared minus 16x. Everything's fitting together perfectly for me. When they're all the same, that means that I have a remainder of 0, which is good. That tells me that this is indeed a factor. If that remainder weren't 0, then that's not a factor and I did something wrong. So when I take this quadratic and this x out of the original, I'm left with this guy. So I'll put him down here. Those are my 3 factors. Now I know that this one can't factor anymore because it stemmed from these irrational roots, but I think this one can factor. Let's see. X and x, 2 and 1, plus and minus. Check that really quick in my head and it works. So that one's out. This is my final answer here. And I'll put the x first. I'm not really sure if the order really matters, depending on what your teacher asks you, but I'll just kind of list all of them. Maybe I should have written the quadratic first, I'm not really sure. But in any event, this is the answer. That's the complete factored version of my original function. So there you go. So when this asks you to factor it, you just basically need to get it down to its simplest form. Moving on, last one. This one has a complex root right here. Same thing here, 3 plus 3i is a root, 3 minus 3i is a root, the complex conjugate. So my factors then, if those are roots, my factors are x minus that. So it's x minus 3 minus 3i. So that's one that comes from here. That's a factor. So this other factor would be x minus 3 minus 3i. So x minus 3 plus 3i. So we're dealing with this and this as factors. So let's go ahead and multiply them together. So over here, x minus 3 minus 3i, x minus 3 plus 3i. Multiply these. So I'm going to do triple distributive again. I'll go a little faster here. X squared minus 3x plus 3xi. I'm doing this into here, into here, into here. Now I'm going to go this into here, into here, into here. And that gives me negative 3x plus 9 minus 9i. This into all three as well. It gives me negative 3xi plus 9i minus 9i squared. Okay. Looks confusing, but again, hopefully things will cancel out. Plus 3xi minus 3xi cancel. Minus 9i plus 9i cancel. The I squared over here is actually a negative 1. If you remember, one of our identities here in complex numbers, imaginary numbers, is that the imaginary unit here, I, is equal to, I guess, the square root of negative 1, otherwise known as I squared equals negative 1. So we make that simple substitution there. So that actually turns into a plus 9. So I have x squared, negative 3x is minus 6x. And I have plus 9 is 18. So there we go. That is a factor. That's what we get when we multiply this factor and this factor together. And what I want to do is simply just divide that out from my original by using long division. So x to the fourth minus 12x cubed, the original, just writing it down. These numbers are a little larger, so it might be a little bit more challenging, but I'll do my best. I always like to challenge myself with these simple arithmetic things just to kind of stay sharp. If I tend to use my calculator too much, I feel myself getting a little bit sluggish when I do these problems. I like to stay sharp. So here we go. I'm going to take and do long division. X squared goes into x to the fourth, x squared times, so put it right here. Multiply back down. I'll go a little bit faster here. Subtract the whole thing in parentheses. These cancel. We get negative 12x cubed plus 6 is negative 6x cubed. 62 minus 18 is 44. Bring this down. X squared goes into negative 6x cubed, negative 6x times. Multiply back down. Plus 36x squared minus 18 times 6 is 60, and 48, 108. Subtract. Remember that minus sign gets distributed all on the bottom, all three of these terms. These cancel. 44 minus 36 is 8x squared. Negative 156 plus 108 is, oh gosh, 156 and 108. Let's see, that's going to be 48, negative 48 x. Bring this down, plus 144. Alright, so now x squared goes into 8x squared 8 times. So I'll put that here. 8 times 8x squared, multiplying back down. These should all match up. 8 times 18 is 144 as well. Subtract, and they all turn to 0. Awesome. So that means this times this gives me my original. So I'll bring these down here. X squared minus 6x plus 18, and x squared minus 6x plus 18. So if I multiply those two together, I get my original. And we already know that this thing can't be factored, right? The factors that come out of this are the complex numbers. And I suppose if you've looked at your discriminant, b squared minus 4ac, let's see if that turns out to be negative. B squared is 36 minus 4 times 1 times 18. 36 minus, let's see, 40 and 32 is 72. Yeah, that is a negative. So that's one way of quickly determining, if a quadratic has what kind of solutions and how many. Can this thing be factored? Let's see, x and x, 4 and 2, minus and minus. That looks good to me. And I'll just bring this down. And I'm finished. That's the complete factored version of my original. So there you go, 20 minutes, 3 examples. I hope it helped. In the future we're going to sort of sometimes go backwards. I'm going to give you some factors, I'm going to give you a bunch of roots, and you're going to give me the equation that it started as. So there you go, there was factoring polynomials when given a root. Thanks for watching.